702 and Cape Talk.
The Naked Scientist.
Good morning, Chris.
Hey, good morning.
I'm fascinated by this week's science story because when we think about tsunamis, we obviously have to, and rightly in the first instance, think about the absolute horror in terms of the catastrophe for the human beings involved. But as the debris gets swept, all sorts of interesting things happen to the ecosystem.
Yep, there's a paper in Science this week which offers us the first and unprecedented opportunity to see what happens when huge amounts of debris goes into the ocean following something like a tsunami, and what species cling to it and where they end up. Because we've known for a long time that obviously humans, there are 7.5 billion of us, are chucking lots of rubbish into the sea. Lots of it's plastic man-made stuff that doesn't break down and it loiters in the ocean for decades. But where does it go, and does it take a cargo of passengers with it? Well, it's very difficult to know because we obviously don't know where things enter the ocean and we don't know what was on them when they went into the ocean. But this paper actually takes advantage of the 2011 tsunami that hit the coast of Japan and also washed away the generating capacity at the Fukushima nuclear plant and caused that disaster, if you remember. But what this paper has done is to say, well, we know on that date, in March 2011, all this stuff went into the ocean because the tsunami swept ashore. It was 38 metres high, the surge from that, and it dragged lots of stuff out to sea afterwards. That material entered the ocean at that point in time, and researchers, including a guy called James Carlton, have been tracking where it's gone for 6 years since. This material has made a 6,000 to 7,000 kilometre journey across the Pacific Ocean, and it's been detected along the seaboard of the US and on Hawaii. They've looked at 600 items that have washed up there, and they've looked at the species which are on those items, and more than 300 different marine species, which include worms, crustaceans, shellfish, small fish. They've made it safely on that 7,000 kilometre journey across the ocean to then become established in America. And the point that they're making in this paper is that actually this shows that very complex communities clinging to things like whole boats, bits of floating dockside, buoys, they can survive and sustain a community in a reproductive state of organisms which can then travel very long distances between continents transoceanically. And that we need to consider this because at the moment, if you look at history, things like wood and trees and that kind of stuff have been going in the oceans for years, but they break down and sink. They don't carry things on these incredibly long journeys, but with very artificial things going in the ocean, like man-made objects, these things don't break down, and they could have the capacity to transfer all kinds of potential invasive species between different land masses. And so we need to be aware of this. We need to be cognizant of it. They don't yet know if any of these 300 species they've found cropping up in America are going to become invasive, but they point out these animals have had a long time to adapt on the 5 or 6 year journey across the Pacific, so they've acclimatized very well. They're showing the mere fact they've survived enormous resilience, so they've got many of the assets that an invasive species would need.
Brilliant, absolutely fascinating. David, good morning to you. What is your question for Chris?
Yes, good morning. Thanks, Eusebius. Chris, I've got a question that when we're sitting sometimes and we doze off, and just in that situation where we're half unconscious, our body gives a sudden jolt. What actually causes that jolt? You know, you sort of suddenly you half unconscious. You sort of not really aware of your surroundings. You're not really asleep, and then you suddenly get a jolt.
Hello, David. This is what we call a hypnic jerk. Hypnic as in hypnos, Greek, sleep, jerk as in, well, a jerk. Not a nasty word for a nasty person, just the muscle movement that you're making. You said it, not me, Eusebius. The reason it happens is we alluded to this a bit last week because we were talking about the concept of sleep paralysis. And when you go to sleep, your brain disengages the flow of information from your motor circuits down the spinal cord to the muscles. And the point of doing this is that you don't want all your muscle groups active when you're dreaming, because you might then act out your dreams and this could lead to injury. So you suppress a lot of this motor traffic going out of your brain. As this system kicks in as you're dropping off to sleep, sometimes it can trigger abnormal muscle contractions and discharges down the spinal cord, making those jerking movements. They're very common, lots of people have them, and it's part of the sleep paralysis system kicking in before you nod off.
Here's one from Twitter. Ask Chris Eusebius, why is it that people who have been taking antidepressants for a long time seem to swell up? Their bodies seem to swell and they lose mobility. Not sure if that's true or false, but do you have an answer for that one?
Well, it's worth considering that people who take antidepressants are probably taking them for a reason. And people who are not happy or depressed and need antidepressants may well have other things going on with their health, and that may be why they're depressed in the first place. A lack of exercise is also linked to depression. If you take exercise regularly, it has a good mood elevating effect, and so it may well be that part of this is a sedentary lifestyle, and perhaps a bit more occupational therapy and exercise would help that person. Sometimes antidepressant drugs can have side effects, and one side effect can influence appetite. And sometimes eating too much is another person's panacea for feeling a bit low. So some people say that they comfort eat, so that may be another reason. So in other words, there are lots of confounding reasons. It may not just be the antidepressant itself. It may be the situation that means the person needs the antidepressant that is leading to the person having these experiences. Sometimes the side effect of the antidepressant drug itself is to boost appetite. So these things could all be working together to produce the outcome the person's referring to. But if this is a new thing, if something's suddenly changed and they're noticing something's changed like this, they probably should go and see a doctor and get checked out.
Grace in Kempton Park, good morning.
Hello.
Hello, Grace. What's your question?
Hi, Chris.
Hello, Grace.
I was busy with making my parents a drink the other day, and I got ice out of the freezer. And I was just wondering, why is it sometimes when you pick up ice, it sticks to your fingers, and other times it just doesn't?
Hi, Grace.
Lovely question.
The reason is that your fingers have a very thin layer or a veneer of sweat on them, so they're slightly damp, and they're also warm. When you touch a very cold ice cube, you transfer to the ice cube some of the heat in your finger, which melts a thin layer of water from the surface of the ice cube. But the surface of the skin quickly reacts to the cold temperature, doesn't have much blood flow. This drops the temperature of the skin, so the thin layer of sweat and water melted off the ice cube freezes onto the ice cube surface, so your finger effectively becomes frozen to the ice cube and stuck to it. And that you can do the same thing, actually, if you have a very cold glass or a very cold drinking vessel or a very cold spoon or something that you've accidentally left in the freezer and then try and eat with it. You can actually glue it to your tongue. You have to be very careful because until the blood returns to the area and warms it up, you have to peel the thing off, and that can take layers of skin off. So be careful. Don't touch very, very cold things with bare skin.
Chris, we're going to take a break here. Here's a question for you to think about. Not that you ever need much time, but I'm loving this one from Twitter. Chris will answer it after the break, and it goes as follows. What scientific way is there, if any, to accurately verify the age of a person without an identity document?
702 and Cape Talk.
The Naked Scientist.
Chris, did you find the answer?
I've been thinking about this, and actually, about 7 years ago, someone phoned up this programme, when obviously it was before your time, Eusebius, with me and Reedy, and they said, yes. Can I carbon date my gran? And actually, the question they'd written in with, they said that according to Homeland Affairs, my grandma was born in 1902. She can't actually remember when she was born. We'd really like to know what her accurate age is. How do we find out? And so we took this on as a little bit of an investigation because we thought it was interesting. And the answer we supplied, in fact, you can go and look that up. If you go to nakedscientist.com and look on there, you'll see we've published the programme we made about this. There's a lady in the Karolinska Institute in Sweden, and her name's Kirsty Spalding. And she actually does research into this very topic, and they've done this in two ways. They do use carbon dating. And the way carbon dating works, it was discovered, and Willard Libby was recognised as the inventor of this technique back in about the 1950s. But the way it works is that in the atmosphere, there is a form of carbon called carbon-14, which is made high up in the atmosphere by the interaction of solar radiation with the Earth's atmosphere. Carbon-14 is being made at a continuous rate in the atmosphere, and it breaks down radioactively at a continuous rate. So there's a steady concentration, give or take, in the atmosphere of carbon-14. It's mostly in the form of carbon dioxide. This means that when trees and plants photosynthesize, in other words, take in energy from the sun, draw in carbon dioxide from the atmosphere and turn it into wood and plant matter that animals then eat. They're fixing that carbon radiation inside their tissue. This means that as soon as something eats that plant tissue and then turns it into part of their body, they have that small amount of radiation in their body, but they stop becoming any more radioactive because the carbon breaks down radioactively. So this means if you know how fast the carbon breaks down into non-carbon-14, then you can work out, based on how much carbon-14 is in something, how old that thing must be. And they're doing this with brain cells. The reason they're doing it with brain cells is that your brain cells are laid down when you are born or before you're born during development. You don't make any more brain cells during your life. Therefore, the carbon-14 in them must have been put there when you were effectively developing. The other way they're doing it is to look at tooth enamel. There's carbon-14 in there as well, and they can use both of these to give very accurate dates to the ages of people. They're doing this on people. Obviously, you don't want to give a chunk of your brain away if you're still alive, and so tooth enamel is probably more attractive to you as a prospect. And since this time, there have been other studies looking at tissues like eyes. People are looking at the lenses of eyes of marine fish, and we have reported on this programme that people have caught samples of Greenland sharks and found them to be maybe 500 years old by doing a similar technique on the tissue in their eyes. So it can be done, and if you want to volunteer some brain tissue, that's up to you, your choice. If you do want to volunteer brain tissue, that argues you probably haven't got much brain tissue to volunteer, but if you don't want to volunteer that, you can use tooth enamel.
There you go, Tulani. I hope you're satisfied by that one. Prince?
Yeah, good morning, Eusebius and Chris.
Hi, Prince.
I have two quick questions. One is, Chris, given time and discipline, will I ever be able to come into your mental capacity? Time and discipline. Two is, will it ever be possible for human beings to upload their consciousness into a computer, just like you will have in this movie Transcended? I think it's Morgan Freeman and Johnny Depp. Yeah, will it be possible to upload our consciousness into a computer and rule?
Yeah,
Thank you.
I mean,
Thank
the
you,
first question first. I don't know the answer to that one in terms of what your cognitive abilities are. Probably very high. And in terms of the second question, do we think that we could turn a human's consciousness into a computer consciousness? Well, could I get a computer to read what's in my mind and then emulate me? At the moment, no, we definitely couldn't. We're nowhere near being able to do that. In the future, could we do that? Well, possibly. With technology being what it is, perhaps we could decode how the brain actually stores information. We know how it stores memories vaguely. We don't know what memories are stored in there. We do know that we have a vague idea as to how the brain stores things. Perhaps we could read those connections, and perhaps we could turn that into computer information. But that's different. Just pure information is very different than a computer thinking how you as an individual think. And this is where this whole argument about artificial intelligence comes from. And this is the real buzzword of 2017. It's suddenly dawned on a lot of very important people that we're on the verge of what people are describing as perhaps one of the most momentous things that will ever happen on Earth, which is we can make machines intelligent. And on the one hand, that's amazing, because if we can give a machine the intellectual capacity that a human has, it will then very quickly massively outperform a human, because it will invent much better ways to do things than we can, because we're constrained by our biology. A machine won't be. On the other hand, it could be very dangerous, because if you think about, there have been all these Hollywood films about things like Terminator. Why did those films happen? Well, the idea was that someone decided to invent a computer program where its goal was to keep everyone having a happy life, peaceful, no wars. Well, the computer program thought, well, if I don't want war, and the only things that cause war are humans, the simple solution is just get rid of the humans. Then we won't have a war, and then I'll have done my job. And so you have to be very, very careful how you program these things. The potential is huge, the opportunities are huge, the return could be huge, but it could also be very, very dangerous. And as a number of very important people, including, I think Bill Gates has said, I don't understand why some people are not concerned. And that's a really important point, that this does have huge ramifications for the planet if we start building systems that have the ability to control us and we can't control them.
Brian, hello.
Hello?
Go ahead. What do you got for Chris?
Yes, I just want to find out from Chris. Right? They say if you have sex with somebody, you leave your DNA you take the DNA and leave your DNA in somebody. So my question is, how much influence does my ex lovers have on my kids' DNA?
Oh, I see what you're saying. Yeah, right, okay. So when we have sex with people, we are exchanging genetic information. That's what sex is. It's a swapping of genetic information with some fun to go with. I mean, I think Richard Feynman said science is like sex. They both have practical results, but then that's not why we do it. We do it often to have fun, and the practical results are that you have some children as well. But when you make a baby, sperm from the man, which delivers half of the human chromosome count, merges with the egg of a woman, which has got half of her chromosome count. And when you put half and half together, you get one, which is you get the full count of chromosomes that a healthy individual is going to need. Now, when we put sperm into somebody, you put millions and millions and millions of sperm inside a lady. That means millions and millions and millions of molecules of DNA, but only one of those sperm ever gets to fertilise the egg to make the baby that's born. So it's one from millions. What happens to the rest of it? Well, they just break down and die. The sperm get killed off, the woman's immune system gets rid of them, and they break down. So lots and lots of DNA is exchanged. Every time you kiss someone, you're exchanging DNA with them. Every time you eat your dinner, you're eating huge amounts of DNA. Plants contain huge amounts of DNA. Animal products and meat contains huge amounts of their DNA. We're putting that in our body, but it breaks down because we have digestive juices and digestive processes that just break it down. So apart from the one molecule, clutch of molecules of DNA in the one sperm that's going to fertilise one egg and make one baby, apart from that one lucky individual, the rest of it just gets thrown away and is not going to have any bearing whatsoever directly and chemically on your offspring unless there are some other passengers to go with, because you can catch infections through unsafe sex, as you well know probably, and you should be very careful because that definitely will have an impact on you and your children and your partner.
Shame, we've lost that last call. I wanted to ask him whether he sees all his ex-lovers in his children. Palesa, hello.
And you see the side, please. I just to find out, why is it that sometimes when you touch a metal door, it shocks you, and sometimes when you touch somebody else, or you hear somebody saying, "Oh, you just shocked me." What is the cause of that? Because it happens also when you're wearing like wool, like when I'm wearing a jersey, somebody touches me, they scream and say, "Oh, you just shocked me." So what is the cause of that?
I love that question, Palesa. Chris has answered the first one many times. The second part is particularly a slightly more novel variation on it. We seem to be able to transfer it as well.
Yeah,
Chris?
so you build up a static charge because people are wearing shoes that insulate them from the ground, and when we move around and rub against things, including the carpet, you get an asymmetric transfer of charge. So you build up a net charge, either positive or negative, on your body, and it can't go anywhere because you're insulated because you've got, say, rubber-soled shoes on. When you touch somebody else, the charge that they have on their body is different to the charge on your body, and the difference between the two is a potential difference, otherwise known as a voltage, and when you touch them, the charge flows. It's a bit like having a big tank of water and a smaller tank of water, and they want to balance out. So the charges flow between you so that you're both at the same potential, the same voltage, and that's the shock you feel. Some people will accumulate a bigger charge or transfer the charge more readily because they might be bigger, they might be wearing the right sorts of clothes, they might be wearing the right sorts of shoes, and they might be in the right sort of environment to build up a bigger charge. And that's probably why some people say, "Oh, I'm a static-y type person." But any opportunity that charge has to leak away from you to balance things out, it will.
Thanks, Chris, for sharing your knowledge with us. We'll do it again
Thank
next
you.
week.
See you soon. Bye-bye.